In this video, we're going to talk about the variance of the sample mean. In the last video, as the English version, which was 2CI number 12, I guess. Let me see. Sorry, it was number 13, the 13th videos, which was variance in linear combination and independence. So we talked about the concept of linearity in variance and how they can be divided without covariance when they're independent. So we're going to use the concept to make sure to be sophisticated with the concept. So we're gonna get started. So today's topic is getting variance of sample mean. So as always, we're going to put the definition of sample mean, which is the sum of every element in the sample and divided by n, the number of sample. So we're going to put the definition here, xn divided by n, which is the same. And we know that invariance is squared form because we know that variance in general is x minus x bar square and its variance of variable x. So we know that if there is a constant inside, it comes out as squared. So n is squared, so it's going to come out like this. So variance x plus 2xn, like this. So now we're going to use the variance in linear combination, the concept that we used in the previous video, that is linear combination inside. And we know that when we put the sample, when we took sample from the population, this is sample, this sample, and this is population, and we took sample each by each with replacement. So because we use the replacement when we're picking out the sample from the population, we can be sure that each sample, each element in the sample, are independent to each other. So we're going to put it like x1, like this, variance x2 plus until we get to variance xn, like this. Because in linear combination, as we dealt with it in the previous video, there's no covariance. Covariance, like x2, this will go 0 because they're all independent. So we can write it like this. So very clear until here. So this is the same as when we got the mean of sample mean. So again, this is population and this is our sample. And when we take out one element from population, the expectation of that one would be mu, which is the mean of the population. And so obviously variance would be the same. It would be the population variance, like this. So this is the concept. So it's always the same when we pick x2 and pick x3. It's always like one element which are picked from the population, and what we did was we just put them in sample like this. So x1, x2, x3, like this. So imagining when we're actually taking samples from population, is always a one element, and when we pick one element from population, expectation would be the same as the population, and variance would be the same as the population of variance, a variance of population. So again here, we know that each of these are same as variance of population because it's one element each. So it'll be 1 divided by n squared and n number of variance. N number of variance in population. And we know that this can be like this and be like this. So we know that variance of sample mean is the variance of population divided by n. So we also can know that the standard deviation of x bar is root to n, like this, sigma divided by root to n. So we're going to use this a lot, and it's the same, right? So yeah, this was what today's video is about, and thank you for watching.